First of all, welcome to this short webinar on cloud computing. We're going to talk about architecting in the cloud, specifically around AWS, which is Amazon Web Services. So my name is Savitra Siroi, and I'll be your instructor tonight. Let me just give you a quick introduction about myself. So I have about 15 years of technology experience, and I've been using AWS for about 6 years now. And one of the things that I was involved in was the design, build, and maintenance of a AWS infrastructure supporting a SaaS business, a software as a service business. And I was also managing the P&L of a technology products business. And in that role, I had to grapple with cost optimization of the AWS infrastructure. This was for a product which was one of the largest databases of its kind, and we had a very large cost problem with both the compute and the storage side, right? So that's one of the things I did. So as you know, this is a short webinar on cloud computing, and this is the agenda. What we will do is we'll talk about basic cloud computing definitions and concepts. We'll talk about attributes such as pay-as-you-go, service models such as platform as a service. All right. So this is general cloud computing, and we'll spend about 10 to 15 minutes on these ideas. In the second section, we'll look at Amazon Web Services, and we'll especially focus on a demonstration of the AWS console. All right. AWS console is where is the thing that you use to manage your infrastructure. And we will look at four key features or key services of AWS. These are EC2, Elastic Cloud Compute, which is essentially the servers. We look at EBS, Elastic Block Store, which is very similar to hard disk volumes. We'll also look at auto scaling. This is a really cool capability. And using this, you can build a fleet of servers which expand dynamically on their own and also shrink on their own based on the criteria that you specify. Okay, and then finally we will look at RDS. This is the relational database service, which allows you to manage your databases on AWS. All right, so I expect that the demo will take about 30 to 40 minutes, and we'll hopefully have about 10 minutes for questions and answers. But please note that please feel free to ask questions during the webinar as well, again using the question section of your webinar panel. All right. Okay, so let's go ahead. I'm going to start with the first section of our webinar, which is cloud computing. So there's a bunch of definitions out there, and this is Forrester Research's definition. As you can see, this is there's a lot of information packed here. I'm going to try and highlight a few key ideas here. So first of all, this is standardized, right? Which means there's no customization. You use what's available. It's the same service that's available to everybody. Secondly, you can see here that these services are internet-based. So you access these services over the internet. It's available from any computer, which is essentially the same thing. Since it's available on the internet, it's accessible from anywhere. This is important. It's always available, 24/7, 365 days. It scales automatically. Right, so actually you can scale it manually as well, but auto scaling is a cool feature. And remember that you can scale up or down automatically, and you can also scale horizontally, which is you can go from one server to 10 or from 10 to 100 horizontally as well. All right, and a couple of other things. Pay-per-use. This is really important. Pay-per-use means that you will be billed the way you are billed for your electricity at home, right, or for your mobile phone usage. right? So this essentially means the more you use, the more you pay, or the less you use, the less you pay. All right. And finally, this also means self-service. So there's no intermediary here. You have your own account, your own console, and you can request services on your own. All right. So this is a very good definition, very comprehensive definition of cloud computing. And when you try to understand this, when you try to digest the various terms that we've covered, please try and compare cloud computing to traditional hardware purchases. Right. So I don't know what your experience has been with hardware purchases, but in my experience, what we used to do is spec out the hardware, create a request or an RFP, invite tenders or bids. Then there would be negotiation, and then you place the order, and then you'd get the hardware in a few weeks' time, right? So there certainly weren't things like pay-per-use, right? You would, in a traditional hardware purchase, you pay a lot of money upfront, and sometimes you pay an annual maintenance fee, which is typically upfront as well, right? So you can see from this definition that cloud computing is very, very different from traditional hardware purchases. Okay. Again, let me remind you, please feel free to ask me any questions. I'll try my best to answer them. All right. Let me move on to the next slide. This is basically we are diving a little deeper into cloud concepts and definitions. There's a lot of information here, and let's start with the top. We talk about attributes or characteristics of cloud computing. So essentially the way this works is there's a pool of resources, all right, and the resources can be compute resources or storage resources or network resources. And these are seemingly infinite resources, right? So no matter how much storage you want, AWS will be able to provide it. No matter how many servers you want, AWS will be able to provide it. All right, so it is seemingly infinite. And then this pool of resources is shared across many developers, many startups, and many other companies, right? And let's look at the attributes now. So these resources are first of all available broadly over the network, over the internet, right? So anybody, anywhere in the world can access these. Second thing is rapid elasticity, which means you can go from a small server to a very large server, right? Say a server which has half a GB of RAM, you can, with the click of a button, change it to a server which has 128 GB of RAM, right? Also horizontally, you can go from one server to 1,000 servers if you like, right? And it also works in the other way. If you don't need the capacity that you have, you can shed that capacity with just a few clicks of the mouse, right? So this is rapid elasticity. Also, it's a measured service, and you pay as you go, right? Again, like utility pricing, in your electricity bill, you are measured in kilowatt hours, right? Similarly, in your mobile bill, you're measured in minutes of talk time, right? And in cloud computing, you're measured in metrics such as server hours, right? So you pay on an hourly basis for servers that you're running. If you shut down the server, right, then you're not billed. Okay. Similarly, for storage, you pay on the basis of GB hours. Okay, so 1 GB, 1 hour, you pay a certain amount. All right. So this is pay as you go. You are typically AWS measures your usage and then bills you on a monthly basis. That's typically how you pay. And finally, this is on-demand and self-service. Right. So first of all, you have your own console. There's no intermediary, and you can just sign on to your console and request a server. And it's on demand because you get the server immediately. Like in a few seconds, you can have a server up and running. All right, so this is basically the key attributes. And again, when you think about these things, please try and compare cloud computing to traditional hardware purchases, and you'll see that cloud computing is much, much better, right? And this is the reason why it is such a big trend, and its widespread adoption is almost a given. All right. Any questions on cloud computing attributes? All right. So I've got a question here from Pavan and Rajiv, and what you're essentially saying is what's the difference between vertical and horizontal scaling, right? Okay, that's a good question. So what happens is a vertical scaling typically means you go from a smaller server to a larger server, right? So, for example, in AWS, EC2, right? These are Elastic Cloud Compute servers. You have a choice of several server sizes and also server types, right? So you could choose, for instance, a micro instance, and this has, in some cases, about 0.6 GB of RAM, right? And I think one CPU. But then you could easily switch to something much larger, right? You could take a double extra large server, and that probably has 128 GB of RAM and probably 8 CPUs, right? So you can just switch very quickly the size of the server. So that's vertical scaling because you're going up in terms of resources. All right. And horizontal scaling is essentially where you increase the number of servers. So you can, say you're in the development stage or a test stage, you may have one server or two servers, and then you go live, you still have maybe 2 or 3 servers, and then if your application becomes popular and you need to go to 100 servers, right? You can do that. You can sort of set up 100 servers running behind a load balancer. Typically, you will need a load balancer to distribute the load across this fleet of servers that you're running. All right, so does that answer your question? Does that explain the difference between vertical and horizontal? All right, so let me go ahead. Any other questions on attributes? So you're right. I mean, see, elasticity is a very key feature, and then pay as you go is a very key feature, right? And these are the two key differences from traditional hosting. All right. So now let's turn our attention to the second section on the slide, right? And you will find terms like SaaS, PaaS, and IaaS, and these have, been very confusing. A lot of people who are new to cloud computing don't really see the difference between these terms. So let's cover this a little bit. So first of all, SaaS, right? So this is software as a service, and what this really means is it's targeted at end users. So, for example, if you are in the HR department of a company or the finance department, and you need to use an accounting package or an HR package, so you would typically buy, nowadays at least, a software as a service, right? So what you are interested in is in using the software, right? The features of the software. You don't really care what goes on behind the scenes, right? So you don't care whether the application is built in Java or in Ruby. You don't care where the servers are or how many the servers are, right? So that is software as a service. Essentially, the users are given a software to use. They don't know anything else about it, and they are typically billed on a per user basis or a per site basis, and they're billed on a monthly basis typically. And users can consume the SaaS offering, and then they can stop using it as well, and they can and then they are not billed, right? So that's essentially SaaS, and it's very different from the traditional software purchases. If you are familiar with that, traditional software purchases were license-based. You had to pay a lot of money upfront. SaaS is different in that you don't have capital expenditure upfront. You have operational expenditure on an ongoing monthly basis, right? So that is SaaS. Now let's talk about PaaS, and PaaS is one of the more confusing items actually. This is essentially platform as a service, and this is one layer below SaaS. Okay, what this means is it is targeted at developers or technology companies who are building their own applications, who are building their own software, and they don't really want to bother with the infrastructure side of things, right? So they don't want to bother about how to scale up these servers, how to do load balancing, for instance, right? Or how to manage database replication, how to do backups of the database. So if you don't want to do all these things, there are service providers who will take care of this for you, and you as a technology provider, you as a developer can focus on your application. Okay, so that is platform as a service. And finally, you have infrastructure as a service. So this is the lowest layer, I would say, because you are actually requesting raw infrastructure. So this could be computing capacity, right, or it could be storage capacity, right? So it's basically infrastructure blocks that you're requesting. So that is infrastructure as a service, right? So please let me know if you have any questions on these aspects, because they've historically been very confusing terms. Okay, so I've got a couple of questions here. One is from Satyavrata, and he says, can you explain a broad network access? Okay, and then I have another question here which talks about how the data will be secure for sensitive databases like financial databases on PaaS. All right. So let me take Satyavrata's question first. So broad network access is basically those resources, right? Cloud computing is essentially resources which are shared across many customers. Okay, so these are compute resources, network resources, and storage resources, and they are accessible. You can access these resources no matter where you are, as long as you have an internet connection, right? So these are not stored in some in a server room that only a certain company can access. They are not stored in data centers where you have to open up firewall ports to access your servers, right? So it's very self-service. No matter where you are, you can access these resources. All right, so that's basically what it means. Okay, so that's broad network access. The next question is on data. I guess data privacy, how to protect data on PaaS. So look, we'll talk about this. We'll in the next section, the bottom half of this slide, we're going to talk about deployment models, and there is something called private cloud. Right, and this is a newish term that has come about in the industry, and what has happened is there used to be public cloud initially, right? Public cloud essentially means the infrastructure is shared across any customer. You may have 2 or 3 companies running their applications on the same physical hardware in some data center, right? So that's public cloud, and that is very good because the costs of the infrastructure are shared widely. So the cost of the infrastructure per customer comes down a lot, right? So public cloud is very cheap, but there are certain industries, say the financial services industry or the healthcare industry, where there's data which is very sensitive, right? And there are a lot of regulations, government regulations, which prevent you from sort of keeping that data in non-secure locations. So first of all, not to say that public cloud is not secure, right? It is pretty secure, and if you read about the security practices of AWS, you'll find that it's pretty secure. There's virtually no chance of data getting lost unless you make a mistake, right, on the application side or in your security practices. But there is this idea of private cloud, which specifically applies to industries like financial services, where the infrastructure is single tenant. All right, so you have, say, a set of servers or a pool of resources which are used only by one customer, say Citibank, right? And the difference is this private infrastructure is ring-fenced, as in the firewalls and the security practices are put in place in such a way that there's virtually no chance. There's no chance that anybody else can access this infrastructure other than the particular customer. All right. So the answer really is in cloud computing, if you are very sensitive to data privacy and data protection, then private cloud is something that you should definitely look at. All right. And while I'm on this topic, let me just talk about hybrid as well. So what happens is, these are cloud computing as an industry, as a sector is evolving very rapidly, right? And private cloud is a newish idea, and hybrid cloud is also pretty new as an idea. And what this means is, you have a combination of public and private, right? Because you want to use public because it's cheaper, because the infrastructure is shared widely, so the cost per unit is pretty low, right? So even a bank has applications, has data which is not very sensitive, right? So for example, a bank may have a learning management system. So that application and that type of data can be in the public cloud, whereas account data, which is very sensitive, or credit history data, which is very, very sensitive from a privacy point of view, can be on the private cloud, right? So there are offerings where you have some applications and some data on private, some on public, and that's what hybrid cloud is. All right. So let me see if we have more questions here. All right. So no more questions. I'm moving ahead. Guys, if you want to come back to this slide, please let me know. This is a really important slide. Okay, let's now talk about Amazon Web Services. So first of all, let me ask you guys, right? What do you think AWS is? Is it SaaS, PaaS, or is it infrastructure as a service? What do you think? Okay, so Shiva is saying it's infrastructure as a service. Rajiv is saying it is all, right? It's all three. Anybody else has any ideas? Is AWS infrastructure as a service? Is it SaaS or PaaS? Okay, some are saying combination of all. Pawan is saying combination. Satyabrata is saying combination. So several people think it's all or some sort of combination. Priyavadini thinks it's PaaS. All right. So here's what I think, right? So essentially, I think it's closest to being an infrastructure as a service, okay? Because you are getting infrastructure like computing resources and storage, all right? But in the recent past, what AWS has been doing has been expanding its suite of services, right? So you now see, for example, here on my dashboard, you can see the full suite of AWS services, right? So definitely things like EC2, I would say, are infrastructure as a service, because these are essentially servers, right? You get the raw server, and then you can build your own server. You have, you can set up an Ubuntu server, for instance, and build it up from scratch. And also storage like S3 is definitely infrastructure as a service. But then if you look at things like RDS, relational database service, right? So this is something where you leave the management of the database, right? Database backup or a database replication to AWS, right? So I would say something like RDS is closer to PaaS, right? Whereas a lot of the other features are definitely infrastructure as a service, right? I wouldn't call AWS software as a service, definitely, right? It's more on the infrastructure side, more on the platform side. All right. Okay, let me just go back to one more question that I missed here. This is from Jayanta Guha, and the question is, can any production database be on the cloud, or it can only be development, test, or build? Okay, so the answer is certainly anything. Definitely production. There are I think thousands and thousands and thousands of companies running production environments on AWS and on other cloud platforms. Right, so there's no reason why you should not have production databases on cloud platforms. And I know AWS pretty well, and I can tell you the security practices are fantastic. Right, you should just look at the security certifications that AWS has, and there have been no major security breaches with AWS. And I would say that there's no reason, right? Definitely production is possible, and certainly development and test are easily possible as well, especially the flexibility that you need with, say, test environments, right? Test environments are environments where you need them off and on, right? You need them now, and then 10 days later, you don't really need them. So the elasticity that cloud provides is definitely helpful when it comes to development and test environments. But I would say the security is fantastic. So there's no reason why you should not use it for production as well. All right. Okay, guys. So let me just move ahead. Let's look at AWS, and like I said, it's I would say a mixture of infrastructure as a service and platform as a service. And I was showing you this particular dashboard of mine, right? And let's look at this a little bit. So there are computing related services, right? There are storage related services. S3 is definitely a place that you should consider if your application has a lot of storage requirements, right? So if you store video, if you store images, right? Log files, anything where you need a lot of GBs of data storage, right? S3 is fantastic for that. CloudFront, for example, is a content delivery network. If your application has users around the world and you want to deliver heavy content, video files or audio files to them, then something like CloudFront is fantastic. There are database-related services. So this is a relational database, MySQL, MS SQL, Oracle. NoSQL is an option, DynamoDB. There are caching servers, and there's also data warehousing, right? So all these options are covered in the database section. And then let's look at one more thing here. So management tools, right? So you have CloudWatch, which is essentially a way for you to monitor your infrastructure, right? So if you've been on the infrastructure side, you know you need to watch for disk space getting full. You need to watch for servers where the memory threshold is being hit, right? So all these things can be monitored very well with CloudWatch, and this CloudWatch will send you alarms or notifications if those conditions are being met. Okay. There's also security and identity, right? There was a question on production environments. So something like identity and access management. This is a service where you can control who has access and exactly what kind of access they have, whether they should have two-factor authentication before they are able to log in, right? So the security and identity in AWS is just top-notch, and IAM plays a key role, right? So this is something that you probably want to master. If you guys are working on the analytics side, right, big data is a big thing now. So you have something like EMR, which is a Hadoop infrastructure that's available on tap for you, right? So you could have a Hadoop infrastructure ready in a matter of seconds. All right. So there's a bunch of AWS services here. And one important thing that I want to point out is there's something called free tier, right? So and most of these services, for example, EC2 has a free tier, and what this means is you can use a small server for free, right? You can use it for free for a period of 1 year, right? So this gives you ample time to experiment with some of the AWS services, right? So if you guys don't have an AWS account, I would definitely encourage you to sign up. You just have to sign up, and then you have to enter a credit card. All right, that's mandatory, but you will not be billed. You will not be charged as long as you make sure that you are using the free tier services. All right, so this is a great way to get started with AWS and to start start experimenting with AWS. Okay, let me see if there are any further questions here. Yeah, so Pankaj, your question is, can we use Hadoop in AWS? So the answer is yes, definitely. Like I showed you on this screen right here, there's in fact a specific service called EMR, Elastic Map Reduce, which is a Hadoop framework, right? It's basically a Hadoop infrastructure. And the other way of looking at it is, AWS gives you servers, right? So if you can run Hadoop on a server in your company or in your own data center, you can run Hadoop on any server in AWS as well, right? But what AWS has done is has made it easier to set up a Hadoop framework. easier than setting it up yourself on EC2 servers. All right. Okay. So let me just go ahead. This is an interesting slide. Just want to cover it quickly. It gives you a good reason as to why AWS, and focuses on the elasticity aspect and the pay-per-use aspect of the infrastructure. Right. So what this is the red line, the red solid line is the actual demand and usage. Right. So if you're, say, a Redbus or a Flipkart, you probably have this kind of usage. There's ups and downs, and then there's a general trend of increased usage. Right. And what used to happen with traditional hardware purchases was it followed this step ladder pattern, right, where you would normally overestimate the demand, right, because you wanted to be safe. You never wanted to have less capacity, so you would pay a lot of money and have more capacity than you need, right. And then once you see that you need more, you again have another step up, right. So this is basically wasted money. But sometimes if you were slow, or if your procurement cycle was too slow, right, and your usage would become more than what you had capacity for, right, so then you would run into problems where you have service issues, your site is slow, for example. Right, so this was the problem with the traditional purchases. And if you see the golden line, right, this is the AWS line, if you will, and you can see it closely tracks the actual demand. And this is because of the elasticity of AWS. Right? You can quickly change the size of the server vertically, or you can quickly change it horizontally, right, in all layers, by the way. So whether it's your web server layer or application layer or your database layer, you can change the configuration of the servers very quickly with just a few clicks of the button. Okay, so this you can review this again later. This is a really good slide which explains why cloud computing is better than traditional hardware. Again, please let me know if you have any questions. Right, please feel free to send in your questions. Okay, let's talk about regions and zones and edge locations. So the way AWS works, although this is cloud computing, AWS has data centers, right? And these are the locations of these data centers, definitely concentrated in the US because that's probably their biggest market, but also available in Europe, and also available, importantly for us here in India, in the Asia Pacific region. Right, so there's a region in Singapore, there's also Tokyo available, and if you like, there's Australia as well, right? And the reason this is important is if your users are in India, you should choose a region which is closest to you, so that the network latency is less, right? So in my case, if I have Indian users, I definitely choose Singapore. Okay. Now, within regions, right? So if Singapore is a region, within Singapore, there are what is called availability zones. Okay. You can look at Singapore here in the bottom right side, and you can see there are two zones, A and B. And what these zones are simply data centers. Okay, zone A is one data center, zone B is another data center, and they make sure that these two data centers are physically far away from each other. Okay, and the reason is if there's a problem, say there's a flooding or there's an earthquake or a tsunami, right? Hopefully, only one zone will be impacted, the other will be running, right? So your application or your infrastructure will not be impacted. Okay, and this gives you an idea, right, what you should do when you use AWS, especially in a production environment, if you have a serious application, you should put your servers in multiple zones, right, half in zone A in this case and half in zone B, right, and then you'll have a load balancer which distributes the load. This way your uptime will be greater. Okay, so this is regions and zones. And also there's something called edge locations. So this is relevant for content distribution networks, right? So if you have applications which are content heavy, say a YouTube-like application, right, or a Ghana-like application, right, where you're streaming video or audio, then you need to have edge locations which are close to your users, right? So depending on an application, if you have a global audience, right, Amazon can help you serve to that, right, because it has edge locations around the world. If you have an Asian audience, you can choose to have only Asian edge locations serve your content, right? So you get billed less, but still are able to serve your customers your content really fast. Okay, so this is regions, zones, and edge locations. Any questions? Okay, so one question Rajiv has is what is elastic, right? Why do we use this term a lot? Now, elastic, it is stretchable, right? So that's what elastic means. And in this in the case of AWS, what it means is you can stretch it. You can either increase your capacity or decrease the capacity, right? Very easily, right? In a way that was not possible earlier. Right, so that's why it is called elastic. All right, so I hope the regions, zones, and edge locations are clear, right? Let me go ahead. Let's now talk about specific services. We have just about 20 minutes, so I'll try and rush this a little bit. So EC2 is essentially servers. Okay, Elastic Cloud Compute. It's basically servers, and these come in various sizes, from very small to very large, right? And of course, you can also choose to have one server or many servers. Okay, this is what EC2 is. A related concept is EBS, Elastic Block Store. So this is the easiest way to understand EBS is to think of it as a hard disk. All right, but it is better than a normal hard disk because it is highly reliable. Okay, it's very unlikely that you lose your data with EBS. Okay, and just like a hard disk, you can attach an EBS to an EBS volume to any server. You can take it out from one server and put it into another server. You can have multiple volumes or multiple EBS volumes attached to a single server, and also you can take a snapshot, which is basically a copy of the volume, so that you can have a backup. All right, so let me show you this. I'm going to show you EC2 and EBS really quick on the AWS console, so you have a good idea. All right, so I'm going to go into EC2. Okay, so this is my EC2 dashboard, and you can see I've chosen the Singapore region, okay, because we are here in India. And you can see here down below that there are two zones, okay, availability zone 1A and 1B. Okay, I'm going to try and launch a new instance, a new server instance. So the first thing I do is to select an Amazon machine image. Okay, so what does an AMI mean? This is basically a bundle of software. Okay, typically includes the operating system, but can also include other packages, right? And it can also include your own application. Okay, so for instance, if you're a LAMP person, a Linux, Apache, MySQL, PHP person, right, then you can have, say, an Ubuntu server operating system, and then LAMP packages. So you'll need the Apache packages, and you'll need the MySQL packages and PHP packages, right? So you can select an AMI like that, so that you don't have to do the work of installing everything from scratch, right? So that's what an AMI means. What I will do is I'll try and find an Ubuntu AMI here. Okay, I'm looking for 14.04. Those of you who are familiar with Ubuntu will know this is like a stable version, right? Ubuntu Trusty it is called, and I'm going to go ahead and select this one here. Okay. So by selecting an AMI, basically I'll get a server with Ubuntu pre-installed, right? I don't have to worry about installing it. Okay. The next thing I will do is select an instance type. Now this is a size that we were talking about, right? So there's everything from micro to very large servers, right? And you can see like micro has one virtual CPU and about 0.6 GB of RAM, whereas there are some which are very large, like this one here has 36 vCPUs and 244 GB of RAM, right? So the whole, there's like a very wide set of choices for you. Please also notice that there's a green sign here which says this is free tier, right? So if you use this, I will not be billed. Okay, so I'm going to select this one for now. Let's go ahead here. Okay, the next thing is the storage, right? So this is your hard disk volume, and this is the EBS that we spoke about, right? You can see the size is 8 GB, right? So the disk is of 8 GB size. I can always change it to something much larger, say 500 GB if I want, okay? But remember that you get billed, the more you use, the more you get billed, right? So I'm going to keep it at 8, which is the minimum here, okay? Let's go to the next step. There's something called security group. So this is essentially a firewall, okay, around this particular server. And you can see by default, AWS is allowing SSH access, right, on port 22. But if I wanted other things, say I want HTTP access, right, because this is going to be a web application, I can do that. I may also want HTTPS, right, so I'll add that. Normally, you don't want to do this, right? You don't want to say that you can access this server from anywhere, right? Normally, you want to give an IP address or a range of IP so that it's more secure, especially for the SSH port. All right. Okay. So that's it. You can see that you can review this. It's an Ubuntu server. It's a micro server with just 0.6 GB of RAM, and it allows invert traffic on SSH, HTTP, and HTTPS, right? And there's a storage volume of 8 GB. Okay, so that's it. I can just click on launch. Again, this is a security feature. AWS works with public and private keys, right? So you need to have a private key downloaded, and this is a one-time download only, right? So if you lose this key, you lose access to the server, right? But this is, a security best practice, all right? I have an existing key. I'm going to use that. So that's it. You can see the log. The server is coming up, and if I click on this server ID, you can see right here that the server is in the process of launching. All right. Please let me know if you have any questions on EC2. Let me just give you a little more information. You can see in the bottom panel here that there's a public IP address, right? So if you want to access this server, you will be using this particular IP. You can see that this has been launched in the 1A availability zone, right? You can take a look at the firewall rules here. Okay, you know that it's an Ubuntu trusty image. Okay, and the key pair is LAMP. There's some information here as well. It's a micro instance. Okay. Any questions on EC2? Okay, so two questions here. One is from Jyoti, and the question is, if I provision many instances, then what about storage allocation for each one of them? Okay, so well, the answer is, if you're launching many instances, for example, if you see here the screen, right, it says launch more like this. So I'm going to launch more of the exact same configuration, right? So this particular server has one storage volume, right, of 8 GB. So if you launch many, the other servers will be exactly like this server. So they'll all have 8 GB volumes attached to them. All right. The next question is from Satyanarayana. He says, what is elastic IP? All right, so this is a very good question actually. Okay, this is a very good question. I'm happy that you noticed it. So what happens is, this is a public IP address, which is temporarily assigned to the server. Okay, what that means is, if you shut down this server, and then you bring it up again, the same IP will not be available. Okay, so this is a temporary IP address. If you want something permanent, right, and there are good reasons why you must have a permanent IP address. For example, if you change your servers, right, or if you change your platform, then it's very hard to change your DNS rules, right? So your company's website will be pointing to an IP address. So it's very hard to change the DNS because it takes a long time to propagate and you can have downtime, right? So it is better to buy an elastic IP address and then associate it with the server. And then tomorrow, if you want to change the server, you can just associate that elastic IP to the new server. So it makes it easy to manage the infrastructure. Okay, so that's the difference between elastic and public. Elastic is a permanent IP address. All right, and you get billed if you don't use it. If you're associated with the server, then there's no billing for an elastic IP address. Okay, so there's one question from Rajiv about subnet. And there's one question from Jyoti about elastic IP free in free tier. Okay, now Rajiv, I think subnet is something that we have to leave for the moment because we'll have to talk about things like virtual private cloud, VPC. It's a different service from Amazon, and it's a longer discussion. We can talk about this perhaps after this session, right? If you hang around. Jyoti, elastic IP address is free. In free tier also, yes, as long as you've attached it to an instance. Okay, so what happens really is elastic IPs are not freely available, are not unlimited. Okay, so what Amazon does is it penalizes you if you're not using it. Okay, and there are good reasons to not use it. For example, if your servers are not being used in the night, you typically want it to be shut down, right? And then when you shut down the server, the elastic IP gets disassociated and it is not used. So when it is not being used and is disassociated, there is a small charge. It's not a very significant charge, but there's a small hourly charge that applies. I don't think that will be free, right? So you may be using a server in the free tier, but if you have an unattached elastic IP, I don't think that will be free. Okay, all right. Now, let me just quickly go to EBS. So this is the volume. Now, I have some volumes of my own, but you can see that there is this particular volume, I think, which is attached to the server we just created, right? And you can see there's the size is 8 GB. And what you can typically do with these volumes is create a snapshot. Right. So, for example, if you're running a database on this machine, you can create a snapshot every night so that you have a complete picture, a complete backup of this particular volume. From the snapshot, you can do something very interesting, which is you can create an image, an Amazon machine image, right? And that image can then be used to launch more servers with all your software packages already installed, right? So typically what you do is you have a server and you have a volume, you install all your application, all your packages, you take a snapshot of that volume, and then from the snapshot you create machine images which can be used for test environments, development environments, and also for production environments. All right. Okay. Now let me just talk about something very interesting, which is auto scaling and load balancer. Okay. Now this is something which most people don't use. I think most people use AWS for EC2 and S3 and perhaps EBS, but something that's really interesting is auto scaling. And the way this works is if your application has spikes in usage, right? So, for example, I've been involved in applications where in the evening, around 5 o'clock, most of the usage used to happen between 5 and 7 in the evening, right? And then the rest of the day, it used to be pretty unused. The infrastructure was unused, okay? But then we were also not sure. Sometimes during the day also there could be a spike in the usage, right? So how do we tackle such a situation? We don't want to keep too much of spare capacity because the cost will be too high, right? So what you can do is you can create a fleet of servers. Okay, so you can say it's a group of servers. You can have a minimum number of servers, which could be 1, and then you can have a maximum number of servers, right? Depending on your needs and your budget, it could be say 20. Right? So minimum 1 server, maximum 20 servers, and then you can have conditions. You can say if the average CPU usage goes beyond 80%, add 1 server. Right? So what happens is as the usage increases, the system automatically detects that the system is overloaded, and it will add more servers as required. Right? And then also the reverse. Once the usage drops off, the system automatically detects that the load is very less, and it starts shedding the servers. It starts terminating the servers so that you're not billed for those servers. Okay. Another benefit, another very important benefit of auto scaling is it can detect if a server is dead. Right. So, like in my experience, I've seen servers which have maxed out on memory, and they are no longer a problem. So the server is not really responding. So auto scaling will detect that one server is not really functioning, right? And it will create a replacement on its own. Okay. So basically, auto scaling is very good for responsiveness, right? So your users have fantastic response from your application, and it is also very good for uptime because it can detect bad servers. All right. So let me know if you have questions. I'm going to show you a very quick demo as well. Okay, fantastic question. Satya Narayana has a question here, says, in case of auto scaling, will there be a request delay to the user as it takes time to launch an instance? Okay, so that's a very good question, and it is true. You know, if the system detects that the overall system is overloaded and it takes time to start an instance, right? Because you need to boot the operating system, and there can be other services that need to be brought up. It could take a few seconds, right? So the answer is what you can do is you can set up a lower threshold, right? So instead of saying that, you know, when my CPU reaches 90% start a server, you can say when my CPU reaches 70% start a server, right? So then you can act faster. All right. So there are ways of managing it, and what typically happens in my experience, what has happened is you try a certain configuration, right, and then if it doesn't work perfectly, you sort of tweak it, you keep improving it in incrementally till you get something that that users are happy with. All right. Okay, so let me really quickly show you how to set up an auto scaling group. So the first step is creating a launch configuration, and this basically, you know, you tell the system what is the software, what is the AMI that you will use, what is the size of the server that you will use. Okay, that's the first step. Let's do that. So again, it's you have to select an AMI. I'm going to go for Ubuntu again, 14.04. You know, depending on my application, I find that micro instance is fine. Okay. All right, let's give it a good name. Okay, so this storage is fine. Let's go ahead. Okay, so this is my launch configuration. Basically, I have selected what is the AMI and what is the type of the instance. Okay, and also the key pair as usual. Okay, now it's time to create the auto scaling group. So we have to give it a good name. And these are the important things here, right? So group size. How many instances do you want to start with? This is the minimum number of instances, right? So you could have 1 or perhaps 2, right? Depends on your typical load. It's good to have the infrastructure in multiple availability zones for uptime, right? So I'm going to select 2 availability zones. Okay, now this is the key thing, right? How do you want to scale this up? So I'm going to say use scaling policies to adjust the capacity of this group. Okay, and we say here scale between 2 and let's say 20, right? So minimum 2 servers, maximum 20 servers. Now you must set a maximum, right, which is small enough because you don't want to be surprised. Right? You can get billed very horribly, right, if you're not watching the infrastructure. So I'm going to set a limit of say 20. Okay, and now here, how do you increase the group size? What are the conditions for increase? So what you do is essentially set up an alarm like this. You say something like high CPU. Okay, and what I'm saying here is the average CPU utilization if it goes above 80%, right? So this is the alarm, and if that condition occurs, add one instance. So every time that the average CPU goes above 80%, one instance will be added. So what will happen is typically you'll add one instance, again it may go up above 80%, so another instance would be added till it reaches 20. All right, so that's how the servers are added automatically. It's very important to set a reverse topic as well. Okay, so what you would say here is if the load is dropping off, right? If the average CPU utilization goes below, say, 40%, then remove one instance. Okay, so the system will automatically stop your instances and terminate them so that your cost is under control. All right, so this is what I wanted to show you. I hope you've understood auto scaling as a concept. Any questions? Okay, so guys, I am afraid we are out of time. If you guys want to hang around, I can show you a relational database service as well. Right, please let me know. I can cover this in any case. We can take 10 more minutes and cover this. All right, so let me just quickly show you relational database service as well. So this is essentially a service which lets you manage your relational database, right? Typically MySQL or PostgreSQL or Oracle or Microsoft as well. And the advantage, right? And first of all, you must know that you can create an EC2 server, right? It's a regular server. It could be, say, an Ubuntu server or a Debian server or a CentOS server, and you can install your MySQL on that. Right, so you could use MySQL, PostgreSQL on a regular EC2 machine, definitely, and that is cheaper, right? RDS is more expensive, but then why use RDS? That is the question. So what happens is if you manage databases, right, you will know that you have to watch disk space very closely because it keeps getting full, right? You know you have to worry about backups. Right? You need to make sure that backups are coming out on time, that you're able to restore them, right? And then if you're doing something more complex like database replication, right? If you have a high availability infrastructure and you need to worry about database replication across data centers, right? That's a real nightmare, right? So this is a very difficult job. And for many companies, you know, small startups, for example, this is something that's too complex, right? So what you can do is use RDS, and Amazon will take care of those things so that you don't have to worry too much about it. So it does things like automatic patching of the database software, right? Security patches and upgrades. It can do the backup for you, and you set the policies. For example, you want backups every night and you want it to be retained for 7 days, right? So you set the policies and then everything is taken care of automatically, right? And other things like point-in-time recovery, right? So if you've done an upgrade to your application, something has gone wrong horribly, and you want to go back in time, all right? These things can be done. You can do it manually, right? But it's difficult. It's complex. But AWS makes it easy. So you just say, look, I want to go back 1 hour before or 1 day before, and just a click of the mouse and you're back in time. Okay, and one very important thing that's not covered here is you can easily do database replication and multiple data center type of configurations with RDS. Okay, so let me just quickly show you. So we go back to the dashboard and go to RDS here. Okay, let's get started. So I'm going to go with MySQL. I'm familiar with it. Okay, so the first question it says is, do you want a multi-availability zone deployment? This typically means database replication, right? So you have a primary database, and then you have the database being replicated onto the other availability zone. And RDS can switch automatically, right? So if it sees a problem in one availability zone, it will switch automatically to the other one, right? So that your application continues. Okay, so I'm not going to do this now because let's say I'm just interested in a development environment, so there's no need for this sort of thing. Okay, these are things like, depending on an application, for most people this doesn't matter, the version of the database engine. Okay, this is the size, right? Just like EC2, you can choose from a wide set of sizes here. So a micro to something which is much larger, something like this, right? Which is 8x large. This is 32 CPUs, it's 244 GB RAM. And I'm sure there are certain applications which require this kind of database. All right. Storage also, depending on your I/O requirements, you can choose whether it should be general purpose or provisioned IOPS. This means it guarantees you a certain performance of input-output. Okay, and provision is obviously more expensive, right? So normally you would choose general purpose, and then of course the storage, right? So you will know your application, you will know how much your database needs, or you can start with something small like 5 GB. You can change this very easily, right? So once you have your database running, if you want to increase storage, it's just a few clicks of the mouse, right? And here you'll give it a name, say something like this. This is your database instance name. You'll have a root user, right? I'm just going to give some username and password here. Okay, the next step. Let's not worry about VPC for the moment. We have to give it a database name, right? So this instance can have multiple databases, but this is just a starting database, if you will. Okay, and down here you can see the backup policies, right? So you want a retention of 7 days or more. You can also give it a backup window. If you don't want any impact to your application, you should normally select a window where there's no usage, typically after midnight. All right, so these are some of the things that you would choose here. All right, so this is something that I'll have to sort of troubleshoot, but I hope you've got an idea of how to create a RDS instance. Please let me know if you have any questions on RDS. Okay, guys, I'm seeing a lot of questions here. Let me just run through them quickly, right? Okay, so there's one from Rajiv. He says, what about a load balancer? So yes, you're right. I mean, that's a good question. Again, you noticed that when I was setting up the AWS, the load, the auto scaling group, I had not specified a load balancer, right? So you're absolutely right. Normally, an auto scaling group would require a load balancer, and this auto scaling group would run behind the load balancer, right? So it's called, that particular service is called an elastic load balancer, or ELB. And there was an option which I didn't show you guys, but I think AWS allows you to create the auto scaling group and then associate a load balancer later. Okay, so definitely you're right, you need a load balancer, but it can be configured with the auto scaling group a little later as well. Okay, Satyanarayana's question is I guess this is about auto scaling. His question is there an option for vertical scaling in the auto scaling group? Okay, so, well, the answer is no, right? So auto scaling is horizontal scaling only. But if you remember, when you're setting up an auto scaling group, what happens is you specify the size of the server that will be in that auto scaling group, right? And in my demonstration, I showed you that we selected a micro instance. Okay, what you can do, of course, is you can select a bigger server, right? So you can change your auto scaling group. You can instead of a micro instance, you can choose a large instance, right? And then reconfigure or relaunch the auto scaling group. So then you'll have the same kind of horizontal scaling, but with larger servers. Okay, so I hope that answers your question. Okay, so there's one question from Rajiv. It would be great if you can talk about VPC. Okay, let me just quickly give you a little bit about VPC. So VPC is becoming a default in AWS, right? So essentially, if you look at this dashboard, right, and if you go back to EC2, and if you try to launch a new instance, normally this will launch into a VPC. Okay, and you can see that there's a default VPC that I have here, and there's a default subnet. Basically, this is VPC is a service which is essentially a virtual private cloud, right? So these are your instances. You can sort of define your network paths and gateways and things like that. You can choose which servers are accessible from the public internet and which servers are not accessible, right? So by default, you launch instances into a VPC right now. Okay, if you have any more like specific questions, let me know, Rajiv. I'll try and answer them the best I can. Right, but basically there's something called EC2 Classic, which is kind of obsolete now, and now all servers are sort of launched into VPC. Okay, Amit Srivastav, your question is, do we need to SSH into RDS? Do we need a PPK and a PIM5 for that? Well, in my experience, I have not done that. You get an endpoint for an RDS instance, and then you have a username and password. And normally, what I would do is I would not connect to the RDS instance from outside, right? So I would only connect to an RDS instance from another EC2 instance, for example, right? So this way, my database is not open to the internet, right? But once I am into an EC2 instance using my SSH key, then I would connect using a password. Okay, that's how I would do it. But I think it's possible to sort of set up a PKI sort of connection as well. Right? I'll have to sort of get back to you if you're really interested on that. Okay, there's some more questions here. Hardeep is asking, where do we choose vertical scaling if not in auto scaling? Well, like I said before, vertical scaling is not possible, right? In an auto scaling group, but there are other ways of achieving it, which is essentially the server type, the instance type that you choose when you set up the auto scaling group. You can choose to pick a larger instance type. Right? So you can, instead of a micro server, you can choose a larger or a double large server as well. So that's how you can achieve some sort of vertical scaling as part of a auto scaling group. So guys, any other questions? So I want to show you, I want to let you know before we end this program, right? We have this this whole course. This is a AWS architecture course from Edureka, and the batch starting on 20th November, right? So I would ask you to consider signing up for this course as well. Okay, so it's 10:15. We are 15 minutes past the allocated time. I think I'll end this session here. Guys, if you have any further questions, please contact us. You'll have the contact information with you, and we can help you with those questions as well. Right? I hope you enjoyed the session, and I hope you have a good night. Thank you.